everyone. Welcome to week 5. I'm sorry it's a little bit late. The weekend snuck up on me and I was planning my 16-year-old's birthday party and a bunch of stuff, and I just lost track of time, and I'm sorry. What we're going to talk about this week are polynomials. And polynomials, you learned about in Algebra 1 a little bit. You talk about them a lot in Algebra 2. So we're going to go over some vocabulary or terminology, and we're also going to cover operations involving polynomials. Operations, I mean adding, subtracting, multiplying, maybe even some dividing, which you've never done until Algebra 2. So I'm not going to teach you dividing, but that is something that you will get to this year. So we're talking about higher order functions, meaning usually above a linear function. We're going to review some vocabulary. I'm going to teach you a little bit of new vocabulary. But what we're going to do first is just anytime you're working with polynomials, you may be asked to simplify them. And that can happen even if you're not adding or subtracting or multiplying them. So the two most common terms that we use when we talk about simplifying an algebraic expression would be the phrase combining like terms, meaning if you see y squareds and other y squareds, you should be able to combine those into one term that contains a y squared. The number in front may change, which is called the coefficient, but there should be just a group. You would have grouped together all your y squareds into one term, all of your y's into one term, and all of your regular constant numbers into one term. Same thing if it were x's or any letter. So when you're given an algebraic expression like this, you are going to look for all the y squareds. You always want to start with the highest power. So I have 3 y squareds, and I'm going to take away 3 y squareds. So that actually leaves none. But then I see 7 more y squareds here. So combining like terms, I end up taking these 3 and combining them into just 7 y squareds. Then the next term would be just the regular y's. I have a minus 3y and another minus 3y. Well, combined, that is a minus 6y. And then I also have some constants. I have a positive 6 and a minus 4. So when I combine those, I get a positive 2. This is my answer, and this is called standard. This is in standard form because we're starting with the highest powered term all the way down to the lowest powered, which is usually your constant that doesn't have a variable at all. Another thing you will be asked to do when you're asked to simplify is to use the distributive property. And remember, distributive property is just multiplication. So we are multiplying negative 3 times negative 3x squared. Well, that would make 9x squared. And negative 3 times a positive 2x would be a negative or minus 6x. And so that would be our answer for this one. Again, it's in standard form. I started with the highest powered term down to the lowest powered term. And we may be asked to multiply or distribute. They could have said distribute, just like this said, distribute, where our powers may need to change. This is an x to the first power. If I multiply a 4x squared by a 4x, the 4's will multiply together to get 16, and an x squared times another x brings it up to a third power. And then I have 4x squared times negative 3, which is a minus or negative 12x squared. All right, so that's reviewing some Algebra 1. Really, even junior high math, y'all talked about combining like terms and distributive property. Now, in Algebra 1, you learned exponent rules, and these were actually on your STAR formula chart for the Algebra 1 STAR test. We learned that if you have the same base and you're multiplying two terms with the same base together, you can add their exponents as a way to combine them into one term. A lot of this is basically combining like terms, but it's with exponents. Quotient of powers would be if you see, and this is supposed to be a fraction bar there, if you see a fraction where you have the same base on top and on bottom, you can combine these two into one term by subtracting the top power minus the bottom power. Whether that's bigger or smaller, the top one, that's not a rule. It is always the top one minus the lower one. Now, if you have a term that has an exponent and that entire term is being raised to another exponent, the way you combine those is by multiplying those powers together. Notice the base continues to stay the same. A times A is not a 2A, it's still an A. All the change happens in the exponent. Now, if there were coefficients in front of these variables, Those, if it's multiplication, would be multiplied. If they were division, it would be divided. If you have a coefficient inside this parentheses raised to a power, you would need to raise that coefficient to that power. If you have a fraction exponent, which is also known as a rational exponent, then this is the way that you are going to deal with that. You are going to take the base and put it inside of a radical. The top power, the power of the numerator of the exponent will go inside with the base. The number that is on the bottom of your fraction exponent will become what's called the index, and it will sit right on top of this little radical arm right here. And that is how you can convert a fraction exponent into a radical. It's also, you can do the reverse. You could take something that looks like this as a radical and rewrite it as a rational exponent. And then one last thing, you're never allowed to leave a final answer with a negative exponent. A number, the base can be negative, but an exponent cannot stay negative. The way you move it, or the way you make it not negative, is you move it. So this was not part of a fraction, so I have to make a fraction in order for that negative to come off of the exponent of n. If you had something that was on the bottom of a fraction with a negative exponent, you would take that particular term and move it to the top so that the exponent could be positive. So you're not always moving it to the bottom. If it's already on bottom and it's negative, you move it to the top. Again, that's the exponent that's negative. You can have negative bases. You can have negative numbers. You just can't have negative exponents. So we're going to practice those rules with some problems here on the back. So this is an example of the power to a power. D is the base. And we're multiplying that exponent of 6 times that exponent of 2, which is going to give us 12. So d to the 12th power. If you want an exponent in Delta Math, you just have to, you can hit Shift 6, and that'll let you put something up in an exponent position. Now this is different. This is the same base, multiplying these two terms together, so that would be a situation where we add those powers together. So c is still the base, but it is now a power of 7. Here we have this similar situation with these exponents of 2 and 3. We're going to be adding those together, but these coefficients, we have to do what this problem says to do, and that's multiplication. Power rules don't work for things without powers. So those are still, this is a multiplication problem, two parentheses next to each other. So the 3 and the 9 are going to be multiplied. What we're going to do to show adding is to combine these exponents. So 2 plus 3 is 5. We can do that here as well. This is 16x to the 4th times 2x squared y. 16 times 2, we will multiply. That would be 32. X to the 4th and x to the 2nd, those are same base. So we're going to add those powers together since they're these terms are being multiplied. And then the y doesn't change because there's no other y to combine it with. Now this is an example of the quotient of powers. We have a 12 divided by 18. We have an x to the 6th divided by x, which you can put a little first power there. That's got just single x. And then a y squared over a y squared. Well, the y squareds, when we subtract those exponents, we get 0, which means those y's go away. A y to the 0 power is not a y anymore. We have a 12 divided by 18, which reduces to 2/3. And we have x to the 6th over x to the 1st. We subtract those exponents, and we're left with 5x to the 5th on top. So our answer could be written like this. It could also be written like this. Either one is correct. And then we've got a power to a power. Now this one's more complicated because x has its own power. Even though you don't see it, it's a 1. And -5 also is going to need to be raised to the 2nd power. So I have 3 things that need to be raised to the 2nd power. I have -5 to the 2nd power, I have x to the 1st to the 2nd power, and I have y squared to the 2nd power. So -5 squared is going to give me 25. X, 1 times 2 is 2, and y, 2 times 2 is 4. And that's my answer. So that's practicing some exponent rules, which we have to be able to do to be able to combine polynomials. So I've already talked to you about what standard form is. Most answers we want written in standard form, which means arranging the terms of the polynomial in descending order. The highest power, which is also called the degree of that polynomial, should be written first, and you will rearrange the terms to go from highest power down to lowest power. Lowest power usually is a constant that doesn't have a variable at all. So can we rewrite this in standard form? Look for the highest power. That would be this one. That should be written first. Look for the next highest power after a 5, and it's a 3. So even though this is a fraction, it's still got a third power, so it will come next. The next thing, that's the next highest power, is an x squared, followed by 8x, followed by a constant. And this would be rewritten in standard form. Now we can practice that even when we're doing other types of problems, like we're going to work with addition and subtraction in this section. So again, we're combining like terms, and then we're rewriting our answer in standard form. So the sum means adding. I'm adding this polynomial plus this polynomial. And so you can write them next to each other. It's fine. You could also write one underneath another, like this vertically, where I'm adding the like terms and I'm putting them next to each other. So when I add these two together, I get a 1x squared. When I add these two together, I get 8x. And when I add these two together, they cancel out. I don't even have a constant in my answer. Subtraction, sometimes it'll already be written as a subtraction problem. This one's more verbal, so you have to read it. It says subtract this from this. That means this is what we are starting with, and this is what we are subtracting away from it. So make sure you read that carefully. We're starting with this. If I say subtract 2 from 10, I'm not saying 2 minus 10, I'm saying 10 minus 2. So I'm going to write this, and I am subtracting from it what they wrote originally. Now, you need to distribute this minus sign to all of those things. So the top stays the same, but because it's subtraction, the bottom, those signs have to change. And so I can now combine these with addition. Once I've done that, that would be negative 11x squared, 14x, and minus 11. So that would be your answer for that one. So please read carefully. Just because it's a subtraction problem doesn't mean it's this minus this. You just need to read that. All right, 1/3 of the way down. Now, multiplying. This is what you're going to do the most in Algebra 2. You're going to be asked to multiply polynomials together. Now, you did this in Algebra 1 with binomials, meaning a two-term polynomial times itself. And here's a good example. Now, you were probably taught FOIL, first, outer, inner, last. Some of you may have been taught the box method, which is where you build a box. If it's 2 terms by 2 terms, that would be a 4 window box. Or you could have just been taught that you're distributing 3x times 2x and 3x times negative 1, and then you're distributing 1 times 2x and 1 times negative 1. That is also called FOIL. So whether you do it this way or whether you do it this way, it makes no difference to me. You're going to get the same answer as long as you're doing math correctly. So using FOIL or the extended distribution, it would be 3x times 2x, 3x times negative 1, positive 1 times 2x, and 1 times negative 1. And if you combine like terms, this is what you end up with. Now you would have gotten that same answer if we had done this box method. You would have combined these two, you would have gotten this. Now, if you're asked, if you're given a binomial squared, please don't just square the x and the 1. This is a FOIL or box method problem. It's just the same thing times itself. If you only square the x and the 1, you will not get the right answer. You're not going to get a trinomial, which is what you're expected to get. So we are doing x times x times 1, another x times 1, and a 1 times 1. And that's going to end up giving you x squared plus 2 x's, these two in the middle, plus 1. If you had just squared x and squared 1, you would not have gotten this middle term. So do not think, if you have something with more than one term being squared, you cannot just square every term in there. You're going to miss something that way. And here's another example. It's a little fuller of an example. So we have 3x to the 4th minus y to the 5th times itself. Okay, so we're still employing the same box method or FOIL. 3x to the 4th times 3x to the 4th. That's going to be 9x to the 8th. 3x to the 4th times negative y to the 5th. I always put things in alphabetical order, so x is before y's. Another negative y to the 5th times 3x to the 4th. And a negative y to the 5th times a negative y to the 5th. which is going to give me a positive y to the 10th. So I'm definitely starting with this x to the 8th. These two combined will give me negative 6x to the 4th, y to the 5th, and y to the 10th will be at the back. And there we go. All right. These are kind of challenge problems, these in group 5. Things that still employ these same ideas, but it may be that you're doing more than one thing. You may be asked to do a subtraction and a multiplication in the same thing. So it says, written in standard form, what is the result when this is subtracted from this? So this is what we're starting with, 6x plus 9, and we're subtracting from it the result of 3x minus 8 squared. So what we need to do is let's find out what 3x minus 8 squared is going to be. It's going to be 3x times 3x, 3x times negative 8, another 3x times negative 8, and a negative 8 times a negative 8. And let's combine those. So that would be this minus 9x squared. I have two negative 24x's, so that's going to make negative 48x plus 64. And all I have to do is subtract. So 6x plus 9 minus 9x squared, positive 48x minus 64. And I'm going to put it in standard form. So this is my highest power, negative 9x squared. I have a 6x and a 48x. That adds up to 54. And I have a 9 minus a 64. That is a negative 55. X minus 4 squared plus 4 times x minus 4. We can distribute that. Minus 3. So let's figure out what x minus 4 times x minus 4 is and put that at the front. So that's going to be x squared minus 4x plus 16. So that would be x squared minus 8x plus 16. And then I'm going to distribute 4 times x and 4 times negative 4 minus 3. So I have an x squared. I have a negative 8x and a positive 4x. And I have a 16 minus 16 minus 3. The 16s are going to cancel each other out. And then another thing that you could be asked to do is you could be asked to multiply something bigger than just a binomial times a binomial. This is a binomial times a trinomial. Well, you could either build a bigger box, 2 by 3 windows instead of 2 by 2, and do it that way. Or you can go ahead and distribute 2x to each of these 3 pieces, and then distribute 5 to each of these 3 pieces, and combine your like terms. Totally up to you. So I'll do that. 2x times 2x squared, 2x times 7x, 2x times negative 6, 5 times 2x squared, 5 times 7x, and 5 times negative 6. And I'll just combine my like terms. Ooh, I missed something here. That's supposed to be an x squared. Okay, my highest power, combining my two x squared terms, combining my two regular x terms, and my constant. And good. Okay, the worst you could be asked to do is multiply 3 terms by 3 terms. So 2x squared times each of these 3, negative 5x times each of these 3, and then 3 times each of these 3. So that would be 6x to the 4th minus 2x to the 3rd minus 2x squared. That's the 2x squared times each of these things. Now I'll do negative 5x times each of these. So negative 15x to the 3rd, positive 5x squared, positive 5x, and now 3 times each of these things. 9x squared minus 3x minus 3. Okay, I think I did that all right. So this is my highest power. Then I've got these two that are both x to the 3rd, so that would be negative 17x to the 3rd. Then I've got 9x squared, 5x squared, that's 14, minus 2, that's 12. That's a minus 17x to the 3rd. Okay, so I've got that and that and that. And then I've got my x's, 5x minus 3x. And then I've got a constant. And then this is one where it's not hard. You just have to think about it. They're telling you use this for the letter B and use this for the letter C. find what 3 times b plus c is. So 3 times what they told me to substitute in for b, those are s's by the way, plus the c value, which is this. And so all you did was substitute in. And so you get 3 minus 6s to the second minus 3s plus 3 plus 5s squared. And put that in standard form. So the s squareds are first. That makes negative 1 s squared. You have only a minus 3s. And then you have a 3 plus 3. That would be 6. All right. I did this already once. I've already... Yeah, that's right. Okay. Now, here's the vocabulary part. And I did write a little bit, so you might just need to read it. Polynomials can be classified or named 2 different ways, by how many terms it has, and also by the value of the highest power, which is called the degree. So if we're talking about the names that we give to a polynomial based on how many terms it has, a 1-term polynomial is called a monomial, mono meaning 1. 2 terms is a binomial, bi meaning 2. 3 terms is a trinomial, and anything with 4 or more terms is just called a polynomial. Like if it had 5 terms, we'd call it a 5-term polynomial. The other way of naming or classifying is by degree. If you have a whatever the highest power of the variable is, and if there's more than one variable, it would be the sum of a 2 variable terms' powers. So if it has just a constant, it is called a constant. If it has a variable with no visible power, which means it's a first power, it's linear. If 2 is the highest power, then it's a quadratic. If 3 is the highest power, it's a cubic. Fourth degree is called a quartic, and 5th degree is called a quintic. Make sure you know what a leading coefficient is. Whatever your highest powered or whatever term determines your degree, then the coefficient in front of that is considered your leading coefficient. It may not be written first originally, but it would be written first if you put it in standard form. Remember that all polynomials have a y-intercept. Whenever you plug in a 0 for x, whatever you get, that would be the value of your y-intercept, the y-coordinate of your intercept. And then the degree is the highest power. If there's more than one variable, like if it's xy in your problem, you would have to add those powers of the x's and the y's together per term to find the degree of that polynomial. So we're going to practice some of that vocabulary. This says, what is the leading coefficient of this polynomial right here? So look for the highest power. It is a 4. What is that term's coefficient? It's a 1. And so that is your answer. That is the leading coefficient. It's just that easy. It's not always written first. If this had been all scrambled, we still would have looked for the highest power, which was that 4, and looked at the number in front of that, and that is called the leading coefficient. What is the degree of this polynomial? So remember, degree, you're looking at what are the variables, just x's. What is the highest power of x? It's a 4. And so the degree of this problem, or this polynomial, is 4. Can you find the y-coordinate of the y-intercept? Plug in a 0. Everywhere you see an x, I see x's in a lot of places, so I'm going to have to put 0 in a lot of places, but this is going to give me 0, so is this, so is this, and so is this. So the y-coordinate is a 0. When there's only variable terms, your y-intercept is going to be 0. However, if it's like this one, where there is a term that does not have a variable, minus 8x squared is 9. All of these are going to give me 0, but then I'm going to have this 9 at the end, so that is my y-intercept of that polynomial. Okay, we're almost done. So let's make sure you know what is not a polynomial, because that helps you determine what is a polynomial. You need to know what the rules are, things that cannot be present in a polynomial. You cannot have negative exponents or a fractional or rational exponent like we saw in those exponent rules. You cannot have a variable in the exponent position. So if your power is where your letter is, that is not a polynomial. A radical with a variable inside. So you can have a square root as a coefficient or as a constant, but you cannot have x or whatever letter is your input variable. It cannot be inside of a square root or any other type of radical. And then the last thing that you can't have is a fraction with a variable in the denominator. If you have a a fraction. 1/9 is fine. That does not have a variable in the denominator. Same with this. Those are okay. But if you had 1 over x or 1 over 4x, that would be not a polynomial. So they want you to answer some questions, and I gave you some examples here. This one, is this a polynomial? It is. How many, what is the power? If you see this drop down, it's going to give you names based on the highest power. So if you look at this, the highest power is a 3, so this is a cubic polynomial, and it has 1, 2 terms. The constant is 1. The number that, the term that has no variable with it is your constant, so that's a 1. The leading term, the whole thing, would be 1/4 x to the third. That is our leading term. We rearrange this in standard form, it would be listed first. And the leading coefficient is just the number part of that leading term. So it's 1/4. Okay, if we look at this next one, I see 4 terms, so I know this. What is the highest power? It's a 4th power, so that is a quartic polynomial with 4 terms. The constant term, if you look at this, the only one of these 4 terms that has no variable is the 1/9. The leading term, so what is it that we circled? We said this is a quartic. That entire term is your leading term. And the leading coefficient is that coefficient in front of that leading term, which is a -1. Now you may also be asked to determine if a given expression is a polynomial. Look at this. 3c to the 5th, there's nothing wrong with that. Plus 7c to the -1, that is a problem. And then minus c, that's fine. What we have here, though, is a rule breaker. We have a negative exponent. We're not allowed those in a polynomial. So this given expression is not a polynomial. If it is a polynomial and you choose is, it's going to pop up with some extra things for you to categorize. But if you say is not, it's not going to bring up anything else. Let's look at that example, the opposite example here. Now here we have -10b squared plus 8a squared c squared plus 10a to the third b to the fifth. Is that a polynomial? All of the exponents are positive numbers, no negative exponents, no variable exponents, and no fraction exponents. So this meets all the criteria for a polynomial. So it is a polynomial, and it is a trinomial. It has 3 terms, and the degree. So this is a degree of 2. Well, this has a power of 2. These two we can add together, even though they're different bases. I'm not trying to combine them. I'm just trying to determine the degree. So this has a degree of 4, and then these two have a degree of 8. Again, I'm not combining them into one term. I'm just looking at the difference. Which one of these has the highest degree? It is this one. It has a degree of 8. And that is it for today.